When you start going down more than 2 pipe sizes on control valves, then you have to correct the CV of what that valve is rated at. Manufacturers will help you with this. They'll have calculators. They're going to have tables. They're going to have some way to break this down. This is just the math that they could be using behind it, so you have an idea of what's going on. So the first thing you have to do is you got to solve for this FP. Well, what's FP? FP is the pipe correction factor or piping geometry factor. There's 2 different formulas you can use. You can use this formula or you can use this formula. This one looks more complicated, but I don't have this sigma K or summation of K, whatever you want to call this here, and then I'm not going, how often if I went to a negative 0.5 exponent, I don't remember ever doing it. I probably did a long time ago in school. So once you figure out what your FP is, you take that times your CV of the valve, so the original valve rating, and you end up with this Cvc, which is corrected valve coefficient. So we'll use that first formula up there just so you can see how it works. So that sigma K or summation K is the sum of the fittings factor. A lowercase d is valve diameter. Anytime you see that in the formulas, an uppercase D is the pipe size diameter. Cv is your valve coefficient, so how much flow can I get across that valve with a 1 psi drop. So in this example, we're going to use 6-inch pipe diameter, which is the uppercase D. We use 1.5-inch valve, so that's the lowercase d, and that valve is going to have a Cv rating of 28. So we see this formula. You can start plugging the information in, but you got to figure out what this summation of K is. So now you have to use this formula to figure that out. So you take 1.5, and then in parentheses you take 1 minus your valve size squared divided by your pipe size squared. So when you plug that into the equation, you end up with 1.5 squared, and you end up with your pipe size squared. So that ends up being 2.25 divided by 36, which ends up being 0.0625. So you take 1 minus that. So then you end up with 0.9375. You got to square that now. So the square of that is 0.87890,625 times 1.5. So that summation or sigma K equals 1.318359375. Now you go back to the other formula and you can plug that in this section here. And then the formula's changed slightly, so you got to put your 28 CV and then your valve size. So we plug that into our equation, and we're just going to focus in this middle section for a little bit. So you're going to end up with 28 CV divided by 1.5, because that's your valve size squared, and that summation of K, so the 1.31, we're not going to go through all these decimals, divided by 890. So next step is you're going to end up with 28 divided by 2.25. If you take this 1.318 and you divide that by the 890, you end up with this long decimal number, and then you're going to end up with this another long decimal number. There's more 4s here. We're just skipping that for now. You square that, 12.44. You end up with 154.86 times this 0.0418, this long decimal. So that and then you add 1. So that answer is 1.229, and you got to take that to the power of negative 0.5. So your FP for that first formula is 0.90. If you use the other formula, we just plug in the information. So again, the D, lowercase d is just valve diameter. Uppercase D is your pipe diameter. CV is what we figured out. So our step 1, we plug that into our equation. So we end up with 1.5. So our valve diameter squared divided by our pipe size squared, 28 CV divided by our valve size squared. So we'll focus down in here. That ends up being 2.25 divided by 36, and 28 divided by 2.25. We end up with 1 minus 0.0625. So we're starting to see some of those same numbers that we were figured in the equation above. And we end up with 12.44. We got to square that. So we end up with that 154.86, which was one of our answers above, and that 0.9375. Now we got to square that. So we end up with 0.87, this long decimal. And then we got to take that times 154. So you end up with that 1.318359375. So if you remember right, that was our summation of K or sigma K. This is that exact same number, except for we didn't have a symbol that we may not have seen before. And you take that times 154, which that was another answer that we had up above. So you end up with the 204 divided by 890, which ends up being 1 plus 0.02293, this long decimal. So then you take 1 divided by the square root of this 1.229, ends up being 1 divided by 1.10878. And then ultimately you come up with that exact same pipe correction factor. It looks complicated. It is kind of complicated. Again, the valve manufacturer is going to have information to do this, or they're going to help you size it. This is just a way to explain it if you see their formulas on how they're solving for it. That way it's not so intimidating.